source and number of current source and number of resistance can be replaced by Thevenins equivalent circuit consisting of single voltage source VTH in the series with single resistance RTH. To find VTH, we need to remove the load resistance RL and find voltage across load resistance. To find RTH, now voltage should be in short circuit and current source should be in open circuit, and finally remove the RL and find the RTH across the RL. Now let's see the proof. Consider the network as shown. Now see the circuit, and using this circuit, current division rule or branch current rule, IL is equal to R2 by R2 plus R3 plus R1 into I. Now to find I, rewrite the circuit and let's take the equation R2 of R3 plus RL divided by R2 plus R3 plus RL. Now R2 is replaced that R2 into R3 plus R2 into RL divided by R2 plus R3 plus RL. Now from the above network, I is equal to V by R1 plus R2 into R3 plus R2 into RL divided by R2 into R3 plus RL. Now we substitute R1 in the equation. Now it's become R1 into R2 plus R1 into R3 plus R1 into RL and R2 into R3 plus R2 into RL divided by R2 plus R3 plus RL. Now substitute equation 1 in the equation 1. Now we substitute means now finally we get IL is equal to R2 into RV divided by R1 into R2 plus R1 into R3 plus R1 into RL plus R2 into R3 plus R2 into RL. Now let's consider this is equation number 3. Now verification of equation 3 by using Thevenins theorem. Now let's take step 1. To find VTH, now we need to remove the RL and find open circuit voltage across the AB. Now we removed RL. Now let's see the equation. VTH is equal to V by R1 plus R2 into R2. Now we find step 2. To find RTH, move all sources network should be in 0 and measure total resistance of the looking in the terminals. Now let's take circuit. RTH is equal to R3 plus R1 into R2 by R1 plus R2. Now it's became R1 into R3 plus R3 into R2 plus R1 into RL divided by R1 into RL. Let's finally step 3. Write the equivalent circuit and connect the load across AB. Now we connected the load across AB. Now we get final equation is IL is equal to V into R2 divided by R1 into R2 plus R2 into R3 plus R1 into R2 plus R1 into RL plus R2 into RL. Now let's consider as equation 4. Now we need to compare the equations 3 and 4. Now we get equal resistance, equal, that both equations should be equal. Hence the theorem is proved. Now let's see the similar Thevenins theorem problem. Using Thevenins theorem, find the current flowing through the 6 ohm resistor for the shown. Now let's see the circuit. Let's start. We need to do step by step. Step 1 is to find VTH open circuit voltage and hence 6 ohm resistor load hence is remove. Remove 6 ohm resistor and find open circuit voltage across AB. We need to find means now apply the KVL voltage I1. Now 4I1 plus 4I1 is equal to minus 2 plus 4. Now this is I1 is equal to minus 2A. Now VTH is equal to VA minus VB of VB minus 0, means that VB is equal to 0. Now VA is equal to VTH. Now VA is equal to 4I1 plus 20 minus 5 is equal to minus 8 plus 20 minus 5 is equal to 7V. Now VA is equal to VTH is equal to 7 volts. Step 2. To find RTH, make all sources in the network should be in 0. Now RTH is equal to 4 into 4 divided by 4 plus 2 is equal to 4 ohm. Step 3 is final is write Thevenins equivalent. Now we see that this circuit, and I is equal to VTH divided by RTH plus RL is equal to 7 by 4 plus 6 is equal to 0.7A. Thank you for watching my video.